Alright, and welcome back. In this video, we are going to be going through Chapter 8, Section 6, titled the Sine and Cosine Ratios. These are the other two ratios I mentioned that we were going to be going through back when we talked about the first of three ratios, the tangent ratios. By the end of this video, we should be able to define the sine and cosine ratios for an acute angle, as well as solve right triangle problems by correct selection of the sine and cosine ratios. So let's have out our guide and notes. Let's begin. So remember where I brought up the SOHCAHTOA. Today we're going to be talking about the SO and the CA of SOHCAHTOA. This is just a way for us to remember the ratios of sine, cosine, and tangent. Previously we talked about tangent being the TOA, so T is equal to the opposite over adjacent. Today we're going to be talking about SO and CA. So sine is the opposite over hypotenuse, and cosine is the adjacent over hypotenuse. On the right hand side there is a older way to remember it as well. Some old horse caught another horse taking oats away. How dare they? My goodness. When I asked them to stop, all they did was say nay. That was a bad one. Alright, the tangent ratio uses only the legs of right triangles. Now, the sine ratio and the cosine ratio relate the legs to the hypotenuse. So the sine of angle A is the leg opposite of angle A over the hypotenuse, and the cosine of angle A is the leg adjacent to angle A over the hypotenuse. And an easy to remember form, sine, not sin, sine is equal to the opposite over hypotenuse, or S is equal to OH, the SO, and cosine, not cos, it's cosine, is equal to the adjacent over hypotenuse, or the CA. C is equal to A over H. On the table on page 202 and many calculators, again, give decimal approximations of the sine and the cosine ratios. And in example number 1, we are asked to express the sine and cosine of angle X and angle Y as ratios. So, for sine of X is going to be ZY over XY, or 12 over 13. For sine of Y is going to be XY, no, I lied, it's going to be XZ over XY, I'm so sorry, is equal to 5 over 13, because sine is the opposite over the hypotenuse. Cosine, again, is the adjacent over hypotenuse. So the cosine of angle X is XZ over XY is equal to 5 over 13. And the cosine of Y is equal to ZY over XY, which is equal to 12 over 13. Notice if there is a pattern. With this in mind, please work on problems 1 through 10 on the guided notes and resume when you're ready to move forward. In example number 2, we are asked to find the values of X and Y to the nearest integer. So we have sine of 38 is equal to x over 84. We're given our degree is 38. And the sine is our opposite over hypotenuse, so x is the opposite, and 84 is the length of the hypotenuse. Cosine of 38 is going to be equal to y over 84. And as we saw it here, x would then be equal to 84 times the sine of 38, and y would be equal to 84 times the cosine of 38, because we're getting those variables all by themselves. We multiply both sides by 84. As we simplify it down, we're going to end up that x is approximately the value of 84 times 0.6157, or just 52. Y is going to approximately be 84 times 0.7880, which is equal to, again, approximately 66. And with this in mind, please work on problems 11 through 14 on the guided notes and resume when you're ready to move forward. In example number 3, we're asked to find the values of x and y to the nearest integer. Looking at our relationship, we have an isosceles triangle with an altitude drawn to the base, meaning that 55 degrees is going to be the angle that we're going to be using, but know that our base we can split up into half in using the value of 7. So, again, it's an isosceles triangle, and the altitude is drawn from the base to the perpendicular bisector of that base. So to find x, we're going to take cosine of 55 is equal to 7 over x. We'd multiply both sides by x, and then we could divide by cosine of 55. Cosine of 55 is approximately 0.5736, so we end up with x is approximately 12.2036, or it's just about 12. To find y now, we can have two different setups. We could say sine of 55 is equal to y over x, because that's our opposite over our hypotenuse. Or we can have the tangent of 55 is going to be equal to y over 7, our opposite over our adjacent. Both ways that we go and solve it, we get that it's going to be approximately 10. They're very, very close to it, but we're able to round and say, hey, y is approximately going to be 10 in both of our methods. With this in mind, please work on problems 15 through 18 on the guided notes and resume when you're ready to move forward. Example number 4, we are asked to find n to the nearest integer. So our solution here, looking at what we have a opposite value of 12, and we have a hypotenuse value of 20. So we would say that sine of n is going to be equal to 12 over 20. So sine of n is equal to 0.6, which means if we look in our table, it's going to be approximately 37. We're going to be talking about other ways to go about finding these values soon using inverse functions, but for right now, this is the way that we are going to be practicing it for now. With this in mind, please work on problems 19 through 22 on the guided notes. Keep up the great work. Keep making yourself proud. Let us know if you have any questions. We'll talk to you soon.